Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe this channel to get alerts. If you like this lecture, please hit the like button. Now let's see the incline to both the planes problem. So here, the projections of straight lines, when a line is inclined to both the reference planes, the projections are given. In the previous video, when the true length and true inclinations are given, we have seen the method of drawing the final projections. But here, the straight line final projections are given, and you are asked to find the true length and the true inclinations with the HP and VP. So here, the front view is given, and its angle, upper end angle alpha in the front view, and beta in the top view are given. So you have to find the true length and the true inclinations, theta and phi. Let us see how. So this is the data given. A is one end of the line is given, A 10 mm above HP, 10 mm above HP, A. One point is taken, that is the front view of A, and 15 mm in front of VP, 15 mm in front of VP. This is point A, top view. So on the same projector, we got the A dash and A, fine. And front view is making alpha, that is the upper end angle. So we have drawn a line here at alpha angle, that is the front view, A dash, B dash are given. And top view is making beta angle, that is top view means AB. So AB is making, this is the front view. AB is making some beta angle here, and the length of the line at this angle is given, that is AB, the top view. So if you draw projectors from either B or B dash, both these projections must be on the same projector here. So now we are asked to find the true length and the true inclinations, that is theta and phi. Okay, so this is the data given to us, and we have drawn the front view as well as the top view of the line. That means here both the lines, front view as well as the top view, are none of these is parallel to the reference line. So the first thing is, in the front view or top view, we cannot see the true length of the line. That is the one thing. Next. So we make some observations here. They are, the point B will be at this height above the reference line. That is passing through B dash, we draw a line parallel to the reference line. That is called the locus of B in the front view. Similarly, in the top view also, we draw a line parallel to the reference line, and we call it as the locus of B in the top view. Now, let's take this top view AB as radius. Top view length won't change. The top view length is the same. Here it is making an angle with the VP. Okay. Now let's do one thing. We'll rotate this line AB. Okay. AB, A as fixed and AB as radius. We'll rotate this and make it parallel to VP. That is AB line now. AB, this point B moves as if it is an arc of a circle, and here it has come. Now AB, this I call it as B1. Okay. So in the top view, we call it as B1. AB1 is the top view of the line, right? And this line is parallel to VP. When it is parallel to VP in the front view, we see the true length of the line. And one more thing we have to observe here is, when this point B is moving as if it is an arc of a circle like this, in the front view, the point B moves along the locus and moves away from A here like this. And finally, when you find B1, the B1 and B1 dash must lie on the same projector here. And we know that the point B lies on this locus and also on this projector. So the intersection of these two is nothing but your B1 dash. That's, I call it as first initial position. In the previous video, if you have observed, when the line is parallel to VP, we call it as first initial position. So here in this position, the line is parallel to VP. Okay, this is parallel to VP. That means in the front view, whatever the length you see is the actual length of the line. That is called the true length of the line. So here we marked that we can measure the true length of the line and also the angle of this line with the horizontal line here is nothing but the angle with the horizontal plane. So this is theta. Theta is nothing but your angle with the horizontal plane. So we are able to find the true length and the true inclination with the HV. Now, on knowing the true length of this line, we can assume the line parallel to HV. So the point B will be lying on this locus. We know that, right? That is to maintain the angle with the VP. So on knowing this true length, this length A dash B1 dash as radius, A as center, we draw an arc here intersecting the locus at some point. We call it as B2. Okay, we call it as B2. And if you see this, this is nothing but AB2 is nothing but the true length of the line. So in the top view, when do you see the true length? When it is parallel to HP and making angle with the VP here. So when it is parallel to HP, we are able to see the true length and also the actual inclination with the VP. Okay, so here, and one more thing, let us we can do the same thing here in the other way also. Like we take this line A dash B dash, right? This is one way of finding the true length and the true inclinations. And there is another way also, that is, we take this front view, this line, and make it parallel to HP. That means front view length is same, there won't be any change. A dash as center, A dash B dash as radius. We rotate this point B downwards until it is parallel to HP. So this line is now parallel to HP. We call this as B2 dash. Okay, A dash B dash and A dash B2 dash lengths are same. So now this is the front view. Now what happens when this point B is moving downwards like this? In the top view, the point B moves towards right side. It moves towards right side. On the locus, it moves towards right side on the locus, as well as when in the top front view, the point B moves along the arc. So point B moves down, and here we got B2 dash, and if we draw a projector from B2 dash onto the locus, we get B2, the point B2 here. So AB2 is how is AB2 now? We made this line AB2, A dash B2 dash, parallel to HP. That means the line is now parallel to HP. A dash AB2. AB2 is now parallel to HP. That means we get the true length of the line here. You can measure the true length of the line AB2. That's what actually we did earlier. When we have taken the true length, because already we have find the true length here, and with the A as center, we draw an arc. That is nothing but this point B2. Okay, so that is one way of finding the angle with VP. This angle is nothing but the angle actual or true inclination of the line with the VP. That is called, in general, we call it as phi. So we are able to find the true length as well as true inclinations theta and phi. So this is the way of, you need not do these two. Either you just rotate one line and make it parallel, get the true length. By taking this true length, you intersect this locus here, and that point itself will be B2. And you need not actually rotate this second again. Okay. Or else, if you want to test, suppose whether I have done it right or wrong, then you can make a test. But in both the cases, you will be getting the same true length. True length is same. There won't be any change. If there is any change, that means we have done something wrong. That is a check. Okay, so this is the way of getting the true length and the true inclinations. And now, if you observe, these are the projections of the line. This is a line parallel to VP, and this is the final projection in the front view. This is the line parallel to HP, and this is the final top view. So here, the locus of B in the front view, top view, and if you observe, we have some certain parameters. They are the true length of the line, right? A dash, B1 dash, or A, B2. Both are true lengths. Second, that is the true length. This is also true length. It may be 100 or something like. Angle with HP, that is theta, right? True inclination with HP, this is called. Angle with VP, in general, these are the notations followed. So, angle with VP, phi, this is phi. And front view, A dash, B dash, front view. And apparent angle in the front view, this is angle which is, the line appears to be making this much angle alpha in the front view. So, alpha, top view, that is AB, the top view. And this is the top view, and apparent angle in top view, beta. Okay, this is beta, the apparent angle. The line appears. This is alpha as well as beta. These two are called apparent angles because the line appears to be making that angle, but not actually. And there is another parameter called distance between end projectors. This AA dash is one end and BB dash is another end. These two are called ends of the line. Projectors drawn through these 2 points is called distance between the end projectors. So here, this is one. So this is another parameter. Why I have drawn all this is, we are given this set of parameters, 8 parameters are there. We can correlate with a mathematical problem like, in mathematical problem, to solve, you will be given some certain parameters and you will be asked to find some other parameters. Here also, this is nothing but a mathematical problem. Like, out of these 8 parameters, you will be given some parameters and you will be asked to find the remaining parameters. That's all. So, to solve these sort of problems, do one thing. Just represent the data as it is. Whatever the data is given, just represent this automatically. Now, the remaining parameters will be, out of all these 8, all the problems in this line inclined to both the planes revolve around these parameters only. There won't be anything new. If you just can understand these 8 parameters, that's enough. And you can do any sort of problem. Okay. Hope you had understood this topic very well. And if you have any questions or queries or any sort of suggestions, please do comment. Do subscribe the channel. Thank you.